All right, question number 7. They want us to find the general form for when is cosine equal to radical 2 over 2. So I'm going to go ahead and visualize where that would be. Positive radical 2 over 2 for cosine would be here or here. This top location would be pi over 4. And again, we're doing the general solution, so plus 2 pi k. For the bottom one, the solution would be 7 pi over 4 plus, again, 2 pi k. So let's go ahead and start by typing that first one in. Oops. We said it was pi divided by 4 plus 2 pi k. And then the next one we said was 7 pi divided by 4 plus 2 pi k. Okay, now finally they want us to plug in 0 for both of these. So if I plug in 0 up here for k, I'm going to get just pi over 4, and down there I'm going to get 7 pi over 4. So let's list those. Pi divided by 4, comma, 7 pi divided by 4, comma. Now up here, if I go plug in 1, that means I'm going to pi over 4, and then I'm going to round that unit circle. So let me see if it'll let me draw in here for us. So again, we're going here, and then we're going all the way around. We're going here, and then we're going all the way around. So I've got a pi over 4 plus 2 pi, which would be equivalent to 8 pi over 4. So when I add those together, I get a 9 pi over 4. And then I would have to go and add on one more rotation. So that means I'd add on another 8 pi over 4, which gives me 17 pi over 4. And then we have to do the same thing for this other solution down here. I'm adding on 2 pi to this one as well. So if I'm adding on, we said a 2 pi here, I'm adding on 8, that gives me 9 pi divided by 4, and let's go ahead and add on another 2 pi to that, which would make it 17 pi divided by 4. So I've got all three solutions from when k is 0, 1, and 2 here. I'm going to do the same thing here. So I already plugged in 0. If I plug in 1, I'm going, again, another 8 pi over 4 around the unit circle, which would be 15 pi over 4, and then again another 8 pi, which would be 23 pi over 4. And now I think we've got all of the solutions. So let's check our answer. Okay, the next one somebody had asked about was number 8, so let's go ahead and look at this one in the same video. First thing I'm noticing is I've got sines and I've got cosines, so I'm going to go ahead and rewrite that cosine as 1 minus sine squared theta. Then I have minus the sine squared theta equals 1 minus sine theta. So I'm going to go ahead and collect my terms and move them to the other side. This would be a negative 2, but when I bring it to the other side, it would be a 2 sine squared theta. I have minus sine theta here, and when I bring that 1 over to the other side, it cancels out. So now I'm left with factoring. I'm noticing they have a sign in common. I've got 2 sine theta minus 1. So when I set each of those equal to 0, I'm looking for when is the sine of theta equal to 0. And when I solve the second one, I'd have when is the sine of theta equal to 1/2. So now thinking about those on the unit circle, and do I have to give, I'm just going from 0 to 2 pi. So that means my sine is 0 at 0 and at pi. My sine is 1/2. Just trying a quick sketch for myself, at pi over 6 and 5 pi over 6. I'm going to go ahead and type in all of those solutions then. So we had 0 pi, pi divided by 6, and a 5 pi divided by 6. Let me give you a minute to look at it, and let's check our answer. And we got it right. Okay, if there's any other questions, go ahead and post those.